Welcome to this geography class. Today we're going to analyze the rock cycle. So, because it's a cycle, it doesn't have a specific beginning or an end. But in order to study the rock cycle, we're going to start with something, right? And we're going to start with something cool, that is a volcanic eruption. So when a volcano erupts, it releases a lot of magma, and that magma is going to go to the surface of the planet, or sometimes the magma gets trapped into the crust. So the first process that we're going to talk today is going to start, right? And the first process comes out from a volcano, directly to the volcano, and this process is called solidification. That means that the magma is going to become a solid, right? It depends where it's cooling down, it's cooling that material, that we're going to have two different types of rocks. We have the rocks that are cooled, the magma that it cools down inside the crust, and we have the rocks that are cooled down touching or outside, exposed to the atmospheric conditions. So, the first type of rock that we have after this process of solidification is what we know as igneous rocks. So, the igneous rocks, that's the name, igneous rocks, yes. Igneous rocks are the first type of rocks that is basically magma, but solid magma. So, like I said, we have two different types of igneous rocks. It depends where they are, right? So, we have the intrusive. So, intrusive igneous rocks, these ones are the ones that are being solidified. They became a solid inside the crust. And we have the extrusive. The extrusive ones are the ones that are exposed to the conditions. It's that magma that you can see, because the intrusive you cannot see them because you need to dig into the crust. So examples of igneous rocks are the intrusive kind. The intrusive are like granite. It's very common in kitchens, granite. The granite is basically pins. It looks like marble, but it's not. Actually, it's not like marble. And you can see the big piece, like a lot of pieces of materials, right? Of minerals, different colors. So one example of intrusive would be the granite, that it cools down really slow because it's not outside, so weather is not helping to cool down. And the extrusive example could be pumice, and also could be obsidian, very, very famous stones here in Mexico, because we have both of them. They are very abundant here in Jalisco. So we have the extrusive kind. Those rocks, if you remember how is obsidian, it looks like you cannot see the crystals, right? Because it cools down really fast. You cannot see the crystal. And with the pumice, it's really light because it went cold is basically the foam of lava. So really, really fast cooling process. So two things can happen. This is the first type of rocks, but we have three. Two things can happen in this process. So in one half, the intrusive, especially the intrusive rocks, are going to form a new type of rock. But actually we have another process, another possibility right here. And this possibility could be for the extrusive ones, the rocks that are exposed to the elements. Do you remember what happens when rocks and materials are exposed to the elements? Weathering process. This is another process. So, weathering process, it's the process where all of the materials, or the sun rays, the UV light, the water, and the heat, but the temperature, it's going to act into the rocks. So, weathering is going to break down the rocks into little pieces. And those little pieces are going to move by another process that is called erosion. So erosion, it's a dynamic process that moves little pieces of rocks. Weathering, it's the process that breaks down big pieces of rocks into smaller pieces that are moved by water and wind. An erosion process. So those exposed rocks are going to form sediments. Sediments, like that? Sediments layers and layers of sediments, pieces of everything, pieces of different rocks, even animals, well, organisms, because these sediments, these layers, if an organism dies in that moment with specific conditions of humidity, temperature, it's gonna become a fossil. So we can find in these sediments, we can find fossils, but we haven't get to the other type of rock. What we need to form another type of rock is that these sediments, these pieces, layers and layers of sediments, they're gonna start getting tight. Maybe because of the, I don't know, the elements, maybe tectonic activity is gonna push down one pieces of those sediments, so they're gonna start getting tired, and that process is called compaction. And also another name of this process, it's called cementation. It's like a cement, so cementation process. They're going to start getting closer and closer to the sediments until they form the second type of rock that is called sedimentary rock. So sedimentary rocks are the rocks made of sediments. So when they start getting so tight, they form a new sedimentary rocks. And this type of rock is very common for construction purposes, like sandstone or asphalt, very common. Even this is a very common rock in the world. You can see that it's kind of, and if you have ever touched asphalt, it's kind of like, you can feel soily, it's kind of feel like dusty because it's made of sediments. Pieces of sediments that are tight and they build a new rock. So if you touch this type of rock, it feels like sandy, right? And one important thing to understand is that even sedimentary rocks, they can form also sediments. What is going to form sediments or how? It would be the same process right here. Weathering, it's gonna affect it's gonna transform the rocks as well. It's gonna start breaking down into the smaller pieces, and erosion, it's gonna transport those little pieces and it's gonna create new sediments. That is very important to understand. Sediments are built of everything, right? So sedimentary rocks. So those are two types of rocks, but we have another one. We have the third kind. And the third kind happens when you apply to rocks. It could be in igneous rocks, or it could be sedimentary rocks that are gonna form this type of rock. But what you need is you need to apply a lot of pressure. And with pressure, if you increase pressure, you increase heat, right? So you need a lot of higher temperatures, a lot of pressure, but not the pressure like the compaction process. No, you need more pressure to obtain this type of rocks, because even with this type of pressure, or not type of pressure, but with this quantity of pressure, you are going to change the chemical structure of the rock. You are going to change the minerals that are built in that rock into something different. And the process to do that, it's a process that is called crystallization process. So if you apply a lot of pressure, a lot of heat, that's why it's very common with intrusive, the intrusive igneous rocks, the ones that are inside the crust. So if you apply a lot of pressure, the minerals from the rock are going to start crystallizing. They are going to change the composition. They are going to form a new thing. So also the sedimentary rocks, if you apply pressure, maybe a tectonic event, maybe an earthquake pushed down sedimentary rocks, and those rocks, millions of years, and they start getting a lot of pressure. So actually it's also with an S. An S is correct. I have seen both. Recrystallization. I have to check my notes because I'm not good at spelling. So recrystallization as well. So what is the name of this third and last type of rock? This is called, and actually the name gives you an idea of what is happening. So it's a metamorphic metamorphic. So that means that it changed the chemical structure. It changed the chemical structure of the minerals that are making up this rock. So a lot of pressure, a lot of heat, both sedimentary and igneous rocks can form a metamorphic rock. One good example of this, the most common example, marble. Marble, if you have ever felt marble, is like really dense material. It's really dense, and actually it's expensive because you need to go deeper into the crust to obtain marble, because marble is not on the surface. Probably it's on the surface when it goes up because of seismic activity, or maybe a volcano. Well, basically earthquakes are the ones that are pushing up materials that we have on the crust, all over into the crust. So that means that sometimes the metamorphic rocks can also form sediments, because sometimes they are being pushed up, right? So also weathering and erosion are going to start, oh, sorry for my terrible handwriting. So weathering and erosion are going to create new layers of sediments. So, as you can see here, basically everything could turn into different things, right? We can turn metamorphic rocks into sediments that after a while, after compaction, they are going to turn into sedimentary rocks. Or we can change igneous rocks into metamorphic rocks as well. But now there's something missing right here, because we don't have a cycle. We have a beginning and we have an end, but a cycle needs to start all over again. So how are we going to start all over again? Well, we need another process, a process to return the things, right? To return to what they start. So that doesn't mean that you are going to carry away, you are not going to carry a big bag of rocks and throw it out in a volcanic crater, right? You are not going to do that. So in order to understand how to begin the cycle, to return the cycle, we need to remember the tectonic plates boundaries, because we have tectonic plates where the new crust is being created, the divergent boundaries. Divergent boundaries, material from the upper mantle is coming up, right? We have a divergency happening in the Atlantic Ocean, and we have new crust coming up every single day. It's been building a new crust all the time, in the Atlantic Ocean. So we need a new process that is called fusion, or also is called melting, but I'm going to use the same name. Fusion, in all of them, even sediments can be fusion. This process is going to affect everything. So where we are going to fusion or melt rocks? Do you remember the convergent boundaries? The convergent boundaries where you have one tectonic plate collapsing on other tectonic plates, and one, the heaviest, goes underneath the other tectonic plates, and in this process that is called subduction process, we are melting the crust, we are melting rocks, because going to the upper mantle, the heat from the upper mantle is going to start melting the crust. So in the convergent boundaries, we are melting the crust, and in the divergent boundaries, we are creating new crust. And also in the with the volcanic eruptions, we are returning the materials going up. So every type of rock can be another type of rock if the process, and now the process, it's a continuous process all the time. Why is it important to understand the rock cycle? Well, basically to understand how we recycle the planet. We are a really good machine recycling the crust. So if you have any questions, just let me know, and that would be all with the rock cycle.